Hello there, this is Professor Shannon Gracie, and we are now on section 2.3, Solving Linear Equations. These videos are a guided, notebook for the Blitzer Introductory and Intermediate Algebra Combo text. And here we go. Today we'll be going over how to solve linear equations, solve linear equations containing fractions, identify equations with no solution or infinitely many solutions, and then use these skills to solve applied problems. So here we go. Why don't you guys go ahead and attack that warm-up and see how you do. Pause the movie and do the warm-up. On your mark, get set, go. All right, let's see how you did. We've got a coefficient of negative 12 in front of that z, so we are going to need to multiply both sides by negative 1/12 in order to get a coefficient of 1 in front of the z. So we'll end up with 1z is equal to negative 12, and that gives us a result of z is equal to negative 12, and we'll put that in our roster notation and call it good. How'd you do? Great. I knew you could do it. Okay, so this next one, I'm thinking that I would like the x's on the left side. So if I were to add 7x to both sides, we will get a result of 6x's is equal to 0x's plus 24. That is equivalent to 6x is equal to 0 plus 24. 6x is 24. Now we need to multiply both sides by 1/6 in order to get a coefficient of 1 in front of the x. So we get 1x is 4, and x is 4. All right, feel all warmed up? Got the math juices flowing? Good. So here we go. We have solved many linear equations at this point in time, and now what we're going to do is just put some steps down for a procedure for solving linear equations. So first off, we want to simplify the algebraic expression on each side. So if you've got like terms or something that you can combine, or if you need to use the distributive property, you would go ahead and you would do that first. Then you collect all the variable terms on one side and all the constant terms on the other side. Then we needed to isolate the variable. So remember, getting a 1 in front of the variable was isolating the variable. And solve. And then it's always, always, always a good idea to check the proposed solution in the original equation. Now, when I go through these movies, I'm going to do steps, 1 through 3 for you, and I'm going to leave the checking of the solutions to you. So that will be left to student. Okay. All right, so now it just is a matter of practice. You know what? You have all of the math skills needed to solve these problems. We covered that in the first 2 sections of the chapter. So what we're going to do now is you're going to pause this movie and you're going to work the next 6 problems and then check and see how you did and see how I solved them. All right, so good luck. Okay, let's see how this went for you guys. Now I'm seeing here for number 1 that we have different ways a person could go about this. I see that we have a negative 1z and a positive 10z there. Over here we have constants, so they're going to be like terms. So I'll get 9z minus 34. So the blue is what happened with these z's on the left side. And that's going to equal to 10z's minus 52. So 2 minus 54 gave us the negative 52. Now I'm going to condense it. I'm going to subtract 10z from both sides and add 34. I decided I wanted my z's on the left side. So we get a result of negative z plus 0 is equal to 0z minus, is that going to be 18, or did I make up my own math? I think we're good. And it's negative because the negative 52 has the larger absolute value. Now this will give us a result of negative z is equal to 0 minus 18. Negative z is equal to negative 18. And if I multiply both sides by negative 1, I'll get a positive 1 in front of the z. I don't want the opposite of z, I want z. So z will equal to positive 18, and we're done. How'd you do? Awesome. I knew you could do it. Okay, so next up, why don't we go ahead and do this one here since it's on the same side of the page, or the same page, and then we'll go down to the next items. So what I'm seeing here is something that we need to use the distributive law on. So this gives us 3 times x plus 3 times 2 is equal to x plus 30. So then we have 3x plus 6 is equal to x plus 30. Now, again, make a decision. What side do you want everything to be on? So I decided I wanted the x's on the left. So if I subtract x from both sides and I subtract 6, because I need to get this 6 out of here, I'll be good to go. Okay. This will give us a result of 2x's plus 0 is equal to 0x's plus 24. This gives us a result of 2x is equal to 0 plus 24. 2x is equal to 24. Now I need to multiply both sides by 1/2 to get a 1 coefficient in front of the x. This gives me 1x is equal to 12. That was times that. And x is 12. How are we doing so far? Good. Alrighty, scrolling down. Number 2, again, we need to apply the distributive law. And you got to be careful with this minus here. I think I'm going to be very careful, and I'm going to just distribute the 8, and then I'll put a grouping symbol around it so I remember to flip the signs. So we're going to get 20 is equal to 44 minus. I'm going to put a grouping symbol here and apply the distributive law. So I'm just doing it where you see the yellow, the positive 8. So that'd be 8 times 2 minus 8 times x. All right, so this is the same as the yellow. Now you could have distributed a negative 8 through, and that would have worked as well. You just have to be careful about that minus sign. Now I'm going to go ahead and and work this inside, we'll get 16 minus 8x's. And when I distribute the minus, I'll get minus 16 minus negative 8x. Okay? So this resulted in this. So now we get 40, well actually we can go ahead and do the 44 minus the 16 to get a result of, is that 28, or did I make up my own math? I believe we got it. 28 plus 8x. Now I've already got my x's on that side, so I'm going to go ahead and just take the constant to the other side. And we will get negative 8 is equal to 0 plus 8x's. And I'll go up here. This gives us a result of negative 8 is equal to 8x. In order to clear that 8 out, I need to multiply by 1/8 on both sides. Remember, you got to balance them out. And then we get negative 1 is equal to 1x. Negative 1 equals x. And that's what we put in our roster notation. How are we doing so far? You guys hanging in there? Good. Okay, so number 3. Again, I see an area where we need to use the distributive law. I'm going to show you another way to do it. Okay. This is going to be where we're applying the negative through. So we're going to go ahead and do this whole negative 4 and apply it to both of those. So we will get 5x minus 4 times x. And then plus negative 4 times 9. And that's equal to 2x's plus 3. So this here is equivalent to that yellow. And you just need to be really careful about your negatives if you do it that way. So then we'll get 5x minus 4x minus 36 equals 2x plus 3. 5x minus 4x is 1x minus 36 equals 2x plus 3. And then, I don't know, just for the heck of it, why don't we get the x's on the right side? So we're going to be subtracting 1x from both sides. And if I'm getting the x's on the right, I need to get the constants on the left. Whoopsie. So now we will have 0x's minus 39 is equal to 1x plus 0. 0 minus 39 equals 1x. Negative 39 equals x. And that's what we put in our roster notation. Negative 39 is the solution to that equation. Very good. Okay, coming back up to number 5. Got a lot going on in this guy. So here's a case where we're going to need to use the distributive law. And over here, we're going to need to distribute the minus through those parentheses. So here we go. 2 times x minus 2 times 15 plus 3x is equal to, now these parentheses aren't doing anything. They're kind of like a shower curtain that's over a shower door. It's just there for looks, okay, to group those two numbers, but there's nothing that needs to be multiplied through them. So I'm going to go ahead and remove those parentheses, and then I'll apply the distributive law to this other area. Do you see we'll have negative 9x plus 2 because the negative distributes to both terms. Okay. And here was the equivalence for the yellow. So this will give us 2x minus 30 plus 3x is equal to, the 6 and the 2 can combine to be 8. 4x minus 9x is negative 5x. I'll go ahead and get the, let's see. So we'll have 5x's combining the 2x and the 3x minus 30 is equal to 8 minus 5x. I'll go ahead and get these x's on the left side this time and the constants on the right side. Okay, so I'll need to add 30 to get rid of that one. So I'll add 30 here, and then I need to add 5 x's to zero out that. So this will give us a result of 10 x's plus 0 is equal to 38 plus 0 x's. 10x is equal to 38 plus 0. 10x is equal to 38. Okay. Now we will need to multiply both sides by 1/10 in order to get a coefficient of 1 in front of our x. So we will have 1x is equal to 38/10, and that can be reduced. 2 goes into 38 19 times, and 2 goes into 10 5 times, and we're done. 19/5 is our result. I know that in your last math class there was a lot of emphasis placed on changing improper fractions to mixed numerals, but we're not going to worry about that unless it makes sense for an application problem. All right? Okay, so here's number 6 on that example. We've got 2 cases on the right side where we're going to need to use the distributive law. Right? So we'll get 100 equals, we're going to get negative x minus a negative 1 is plus 1. And then plus 4 times x minus 4 times 6. Here's the yellow, the end result of the yellow, and here's the blue. So we'll get 100 equals negative x plus 1 plus 4x minus 24. 100 equals 3 x's combining the negative x and the 4x minus 23 combining the positive 1 and the negative 24. Now I'm going to go ahead and get the constant to the other side. And we will have 123 is equal to 3x plus 0. $123 is equal to 3x. And if we multiply both sides by 1/3, we'll get a 1 in front of that x. So 3 goes into 123 41 times, and that's equal to 1x, so 41 equals x. And in our roster notation, we'll put 41. That is the solution to the equation. Did you guys do all right on these? I know it's a lot of information, but remember, just take it step by step, and you can do it. And with enough practice and enough, time put in, you can really do this. I promise. Okay, so here we go. Linear equations with fractions. Well, we've already dealt with some of them, all right? A lot of people believe that equations are easier to solve when they do not contain fractions. So this is going to be something that, you'll have to decide the best way for you. Personally, I believe fractions are your friends. So if you want to use fractions, that's fine. But you can remove them. All right, so to remove fractions, we can multiply both sides of the equation by the least common denominator of any fractions, whoops, sorry, in the equation. Remember, the LCD is the smallest number that all denominators will divide into. This is often called clearing an equation of fractions. Okay, so here we go. So this is sort of like solving linear equations on steroids, all right? We've, again, this is going to be up to you how you do it. Personally, we've got, in this case, I'm going to tell you straight up, I don't always think, I'm going to show you this skill, and you're going to have to decide the best way for you to solve these problems, all right? But here it goes. All right, so using this skill, we would need to multiply both sides of the equation here by 2, because 2 is the only denominator. Other, these have kind of denominators of 1. So this would give us 2 times x over 2 plus 2 times 13. It's important to write the line that I'm writing. And then 2 times negative 22 is negative 44. It's important to show the distributive law, because the main mistake that students make on problems like this is they forget to multiply the second term by 2. Right? So then 2 times x over 2, do you guys see the 2's will divide out, and we'll get x plus, well, I guess we could write 1x plus 26 is equal to negative 44. Subtracting 26 from both sides would yield a result. 1x is just x, and then we'll have plus 0. And this one, negative 44 decreased by 26, is going to give us negative 70. So x is equal to negative 70, and we're done. Oops. We'll put it in our roster notation. Okay? Alrighty. So many of you may have noticed that problem, it might have been easier if we had first subtracted 13 from both sides and then solved it using, our other methods. But I just wanted to show you how to do it so you'd have an example. Okay, now I'm going to show you this one. This one's a little more complicated. All right, so here, in order to clear the equation of fractions, we need to figure out the smallest number that 5, 2, and 6 all divide into, and what is that going to be? Good, it's going to be 30. So we're going to multiply both sides of the equation by 30. Again, we're going to need the distributive law for these. So this is 30 times z over 5 minus 30 times 1/2 is equal to, now this one is just, do you see that the 6 goes into itself once and into 30 5 times? So we'll get 5 z's. And the result of the distributive law is shown here. Okay, so here 5 goes into itself once and into 36 times. And over here 2 goes into itself once and into 30 15 times. So our next line will be 6z minus 15 is equal to 5z. And then if we subtract 5z from both sides, and then, we would want to add the 15 to both sides, we will get 1z plus 0 is equal to 0z plus 15. That will give us z is equal to 0 plus 15. Z is equal to 15. Right? Okay, so now it is your turn. You need to pause the movie and you need to work numbers 3 and 4 and see how you do. Okay, you can either clear the fractions or not, but just make sure you get the correct answer. On your mark, get set, go! You can do it. All right, let's see how you did on numbers 3 and 4. Whoops. Okay, so for number 3, I'm looking at this 4, 3, and 12. The smallest number that they all divide into is, you got it, 12. So we need to use, what was that law called? Good, the distributive law, or property. On that side, we will get 12 times 3y's over 4 minus 12 times 2/3 is equal to, now on this side, the 12 completely divides out and we'll just get 7. And so here is the result of using the distributive law. And now 4 goes into itself once and into 12 3 times. 3 goes into itself once and into 12 4 times. So here we'll get 9y, because we're doing 3 times 3y is 9y, minus 8, 4 times 2 is 8, equals 7. And then isolating the variable term, we will add 8 to both sides. 9y plus 0 is 15. 9y is 15. So now we need to multiply both sides by 1/9 in order to get a coefficient of 1 in front of, coefficient of 1 in front of the y, the term with the y. So we'll get 1y is equal to, now let's see, 3 goes into 9 3 times. Actually, you know what? I'll do that in the next step. I don't want you to be confused. So we'll get 15/9, and we can reduce that 15/9 to be 5/3. So y is equal to 5/3. Are you hanging in there? See, fractions are your friend. They're not bad. All right, number 4. There we go. In order to clear the fractions here, the least common denominator would be 12. Okay? I'll be applying the distributive law here. we'll get 12 times x minus 2 all over 3 minus 12 times 4 is equal to, over here, 4 goes into itself once and into 12 three times, but you're going to have to distribute the x plus 1 times the 3. Okay? So that's going to end up being x times 3 plus 1 times 3. That's the result of the blue. And the yellow, of course, was this result here. All right. We can simplify that a bit. 3 goes into itself once, into 12 four times. And so now we're going to have 4 times x minus 2 minus 48 is equal to 3x plus 3. And now we got to use the distributive property yet again. So we'll get 4 times x minus 4 times 2 minus 48 is equal to 3x plus 3. This is the result of that distribution. So then 4x minus 8 minus 48 is equal to 3x plus 3. And we can combine that negative 8 minus 48 to be 4x minus 56 is equal to 3x plus 3. I decided I want the x's on the left side. So we'll subtract the 3x from both sides, and I got to get rid of that 56. So I'll add 56 to both sides. And at the end of the day, well, almost the end of the day, we get 1x plus 0 is equal to 0 x's plus 59. And then this just gives us a result of x is equal to 0 plus 59. X is equal to 59. And you box your final result. Okay. Recognizing inconsistent equations and identities. This is very important. You have to be comfortable enough with this topic so that you know when something looks strange or doesn't look okay. Right? So here we go. Let's check it out. If you attempt to solve an equation with no solution, or one that is true for every real number, you will eliminate the variable. If you keep working on it, you will eliminate the variable entirely. Okay. An inconsistent equation with no solution results in a false statement, such as 0 equals 5. You know, that's not true unless you already went and had a few margaritas before you watched your math movie. Right. Okay. An identity that is true for all real numbers results in a true statement, such as 0 equals 0. That is definitely true. Okay. So let's check it out. Example 3. Why don't you guys, well, we'll just do them together. If you'd like to pause the movie and work on them on your own, that's totally fine. So here you see we need to use our distributive law. So we'll get 2 times x minus 2 times 5 equals 2x plus 10. This is the result of the distributive property. Then this gives us 2x's minus 10 is equal to 2x's plus 10. Now, if I want to get the x's on the left, I would need to subtract 2x from both sides. And if I want to get the constants on the right, I would need to add 10 to both sides. This will give us a result of 0x plus 0 is equal to 0x plus 20. So then 0x, remember, is 0, so we'll get 0 is equal to 20. What do you think about that? Is that true? It's not true to me, right? So here we go. This is a false. This is false, right? So what that means is that there is no number that you could plug in for x that would ever make this statement true. So the way to say there's no number that'll work is to put empty roster brackets. Now, another alternative notation that you'll see is this. This means the null set. Okay? Or the empty set. Okay? Actually, they both mean that. Okay? And so I'll take, either one of those. All right, so let's try the next one. Notice that we're going to need to apply the distributive property there. So we'll get 5x minus 5 equals 3x minus 7 plus 2 times x plus 2 times 1. Here's the result of the distributive property. Cleaning it up, we will get 2x plus 2 at the end. And then we can combine some like terms on the right side. 3x plus 2x is 5x. Negative 7 plus 2 is negative 5. So you might be seeing something interesting, but you can keep going if you want. If we want our variables on the left, we would need to subtract 5x from both sides. And if we wanted our constants on the right, we'd need to add 5 to both sides. So this will give us a result of 0x plus 0 equals 0x plus 0. 0 equals 0. Is that true? You are right. It's definitely true. So what that means in this case is that it doesn't matter what number you plug in for x. It'll always work out. It'll always be a solution. So now the way that we say this in Mathese is we write a set. We build a set. It's called set builder notation. And you write the name of the variable, which is in this case is just x. A line like this, which means such that. And what is x? X is a real number. And yes, you have to write that. That is the answer. Okay. And let me just make it clear. The such that is this line right there, stands for such that. Alrighty. So let's look at number 3. Number 3, I would go ahead and subtract 3 from both sides to make this a little bit easier. And we'll get x over 2 plus 2x over 3 plus 0 is equal to x plus 0, which will give us x over 2. Actually, I'm going to, oh no, that's fine. X over 2 plus 2x over 3 equals x. Now, in order to clear these fractions, we need to multiply both sides of the equation by 6. And again, we'll be distributing on the left side. So we will get, let's see, 2 goes into itself. Oh, nope. See, that's not something I want you guys to do. It just ends up causing a lot of heartache. So we'll do it at the next step. So 6 times x over 2 plus 6 times 2x over 3 is going to equal to 6x. Sorry, I'm at the edge of the page here. And this, the left side, that's the result of the distribution. So now we can say 2 goes into itself once and into 6 3 times. 3 goes into itself once and into 6 twice. And we'll get 3 times x plus 2 times 2x is 4x. And that's equal to 6x. 7x is equal to 6x. Subtract 6x from both sides. We will get 1x is 0 x's. So that gives us x is 0. Now, do you see how this is different? We got x is 0, whereas on the other ones, we ended up with a constant on either side of the equation. It's okay if x is 0. That means that 0 is the only number that will make this a true statement. Oops. All right. Let's divide this up. And I went a little into this guy's space. Okay, so let's check this out. Now here, you can go through, you can clear the fractions, but do you see that they already have a common denominator? So if we subtract x over 4 from both sides. So I'm getting the x's on the right side of the equation. What happens? Do you see that we're going to get 0x over 4 plus 3 is equal to 0x over 4? So that gives us 0 plus 3 is 0. 3 is 0. What do you think about that? That's right. It's not true unless you had your margaritas. Okay? 3 is certainly not equal to 0. So therefore, what is our answer? Good. It's I like using the empty set. So it's the empty set. All right. Very good. Okay, now we're on to our last page in this section. Okay, so let's take a look at an application. So with this particular application, the formula P equals 15 plus 5 times D divided by 11 describes the pressure of seawater P in pounds per square foot at a depth of D feet below the surface. So in the first part, let's get some room here. The record depth for breath-held diving by Francisco Ferreras in Cuba off Grand Bahama Island on November 14, 1993 involved pressure of 201 pounds per square foot. So they're asking us to what depth did Francisco descend on this venture? He was underwater for 2 minutes and 9 seconds. So that's pretty crazy. So remember your general formula here. Sometimes it's good to go ahead and rewrite that formula. So P is 15 plus 5D over 11. Oops, sorry. All right, P is 15 plus 5 times D over 11. So let's see what information we've got. We've been given the information that we've got pressure, P, of 201 pounds per square foot. So here, this P will plug in 201 in for P. And then what we need to do is isolate our D. Okay. So to that end, what we'll do is we'll go ahead and we'll subtract 15 from both sides. And we get, let's see, 11 minus 5 is 6, 9 minus 1 is 8, so 186 is equal to 15 minus 15 is 0, so then we'll get 5D over 11. Now what we need to do is we need to multiply both sides by 11/5 because we need to have a coefficient of 1 in front of that D. So here, when we do 11 times 186, we're going to get, let's see, well, if we do it on the calculator, you're going to get 2,046, right? And that's going to be over 5 equals 1 times D, because these will all divide out to be 1. And then when we divide 2,046 by 5, we end up with 409 and 2/10 is equal to D. So let's put our answer in words. So Francisco dove to (409 and 2/10), and the unit will be in feet. All right, so we're all set. Now let's take a look at our next part. Okay, so this next part is having us find the depth where the pressure is 20 pounds per square foot. So again, we'll put our general formula for this that describes this equation, and then the pressure given this time is 20 is equal to 15 plus 5 times D over 11. So this is what we plugged in here. And again, if we subtract 15 from both sides, we will get 5 is equal to 5 times D over 11. And then multiplying both sides by 11/5, nicely, these divide out this time, so we will get 11 is equal to D And let's just double check our work. I think everything is looking good here. Perfect. And put our conclusion at a depth of 11 feet. The pressure is 20 pounds per square foot. And we're all set. So don't forget to do your homework and have a fabulous day.